So in this video, I'm going to look at some examples of finding higher order derivatives. For instance, this first one, I'm going to start off with number 1, which is 4x to the 3 halves, and I want to find, in this case, the second derivative. Notice there's 2 apostrophes there, so that's telling me I want to do the second derivative of f of x, and we're starting with f of x. So what I'm going to do is I'm going to differentiate this twice. So good thing for us, this is actually a x to the exponents. This is actually going to involve the power rule. And since there's this 4 out front, it's also going to involve the constant multiple rule. So hopefully I'm just going to put this back together. So let's see. If I apply the constant multiple rule, I'm just going to keep this 4 out front, times, I'm going to do the power rule. So it's going to be, you notice this exponent up here is 3 halves. So I'm going to multiply out front by 3 halves. And what I'm going to do from there is I'm going to subtract the exponent. So it was 3 halves minus 1 is going to leave me with 1 half. Okay. Now, in order to finish this problem, I'm just going to actually simplify this a little bit. So 4 divided by 2 leaves me with 2, times 3 gives me 6x to the 1 half. Now, if you wanted to, you could rewrite that as 6 times the square root of x. But, again, this is just my first derivative. And that's not really what I'm looking for here, is I want the second derivative. Well, I have to find the first derivative and then take a derivative again. So I'm going to have to apply the same rules in this case. I'm going to do the constant multiple rule with this 6, and then I'm going to do the power rule with that x to the 1 half. So, again, keep the 6 out front, apply the power rule. So the 1 half is going to come out front, and x, and we're going to subtract that exponent by 1. So 1 half minus 1 gives me a negative 1 half. And I want to go ahead and simplify this a little bit again. 6 and then 2, that's going to give me a 3 times 1, so my coefficient will be a 3. And I've got this negative exponent, and I don't really like leaving negative exponents, so I'm going to move that to the bottom. And so I'll write it as x to the 1 half. And again, I also don't like leaving fractions in my exponents either, so I'll write it as 3 divided by the square root of x, and I will happily leave that as my final answer. If you really wanted to rationalize that denominator, that's fine too. You could write it as 3 square roots of x over x, but honestly, I'm going to leave that one as my best answer because I don't really want to do anything extra if I don't have to. On number 2, I'm going to have to do the same kind of idea. It's asking me for g prime or g double prime of x. And so what I want to do here is I want to find the second derivative of g, which is this function here. So I'm going to have to find the first derivative and then do the second derivative. Now, in this one, it's a little bit different because you notice I've got x times sine of x. So what I'm going to actually have to do here is do the product rule. So this is going to be my first function, and that's going to be my second function. So if I take the derivative of just x, we get 1 times sine of x, plus, and I'm going to take the derivative of sine of x next, which is cosine, and I'm going to keep that x in front of it. So notice again, we took the derivative of x and got 1, and I kept the sine. Then I took the derivative of, the sine and got cosine, kept the x. All right, so that's my first derivative. So I'll write that as g prime of x. From here, what I want to do is, again, I'm looking for the second derivative, so I want to apply it again. Well, the important thing is that 1 times sine of x is really just sine of x. So I can take its derivative, which is, and I'll write this down, derivative of sine of x is just cosine of x. Now, hard part about this one is I do have to do the product rule again, and that's pretty common with any of these higher order derivative questions, is to have to repeatedly use the same kinds of rules. So again, I'm going to start off by taking the derivative of just the x first, which is going to give me 1, times my cosine x, okay? Then I'm going to add, and I'll take the derivative of cosine x, which is negative sine of x, and I'll keep the regular x that was out front. And so I'm just going to simplify this a little bit. Again, 1 times cosine is just going to give me cosine. But then I have another one here, so that means I have 2 cosine x's. And I don't really want to have a plus and a minus, so I'll just write minus x sine x. All right, so that kind of handles that problem. I'm going to pause here and come back and finish the rest of these problems. Hopefully you guys are ready, and let me know if you have any questions.